Welcome to physics chapters.
Let's see second numerical related to the second property of dimensional analysis, which is to derive the relation between various physical quantities. The here given question is, assuming that the mass m of the largest stone can be moved by a flowing river, depends upon the velocity v, the density rho, and the acceleration due to gravity g. Show that the mass m varies with the sixth power of velocity of flow. So here it is given that the mass is directly proportional to the velocity, density and acceleration due to gravity. We have to prove that the mass m varies with the sixth power of the velocity, means m is directly proportional to the v raised to power 6. So it is given that mass m is directly proportional to the velocity v. We'll take v as raised to power a. M is directly proportional to density raised to power b. M is directly proportional to the gravity, acceleration due to gravity g raised to power c. So we can write this as m is directly proportional to v raised to power a, rho raised to power b, g raised to power c. So m is equal to proportionality constant. We'll put here k, v raised to power a, rho raised to power b, g raised to power c. Now we'll write the dimensional formula for both sides. The dimensional formula for mass is m. We don't have any L and T. We will put here L0, T0. For dimensional formula for k is the dimensionless constant. So now we'll write the dimensional for velocity, which is L, T minus 1 raised to power a. For the density, the dimensional formula is L, m, L raised to power negative 3 raised to power b, and the dimensional formula for g is L, T minus 2 raised to power c. Now we'll combine all the powers on the right hand side. So here, this is here I have only this m, so this will be m raised to power b. So L raised to power a here, and L raised to power negative 3 multiplied by b will get minus 3b, and here L raised to power c plus c. So similarly for t, we'll write t raised to power minus a and minus 2c. So left hand side it is like this, m raised to power 1, L raised to power 0, t raised to power 0. Now we'll compare the powers of m, L and t on both sides. So here the power of m is b, here is 1, so it is 1 is equal to b. L, it is 0 is equal to a minus b plus c, and here for time is equal to 0 is equal to minus a minus 2c. So from here I'll get b is equal to 1. So from here I'll get a relation between a and c. So it will be like a is equal to minus 2c. So I'll put this value here. So I'll get 0 is equal to minus 2c minus 3b plus c. So this will become minus 2c and plus c. Minus c minus 3b is equal to 0. So I'll get a relationship between c and b, which is my c is equal to minus 3b. My b is equal to 1. So I'll put here 1. So I'll get c is equal to minus 3 into 1. So I'll get my c is equal to negative 3. So I'll put this value here. So I'll get a is equal to negative 2 multiplied by negative 3, which is equal to 6. Okay, so a is equal to 6. Now I'll put all these values in this equation. So from here I'll get m is equal to k, v raised to power a, which is 6, rho raised to power b, which is 1, and g raised to power c, which is equal to minus 3. So I can write this equation, m is equal to k, v raised to power 3, rho, and g raised to power divided by g raised to power 3. So this is my relation, and so for this from this relation it is clear that the mass is directly proportional to the here it is 6, and from this formula it is clear that mass is directly proportional to the sixth power of velocity. m is directly proportional to the v raised to power 6.